Welcome to this Amazon Web Services course. I hope you're as excited as I am when it comes to working with AWS, since it is a fantastic skill to be able to develop, launch, and run applications without worrying about servers and hard disks and networks and so on. Once you have mastered this skill using this course, you can choose to use it for your own business or you can use it to land a high paying job in a firm that is already trying to implement AWS. So let's take a look at what is AWS and why might we want to use it. AWS refers to a suite of cloud computing services that allow us to export all the physical hardware requirements of our company to Amazon, leaving us the time to work on designing the software for our applications. The way this works is Amazon has data centers spread throughout the world, and these data centers house racks of databases, storage devices, routers, and servers all booted up and ready to go. When you request access for one of these machines through the AWS Management Console, it becomes available to us immediately and you can operate it from anywhere in the world using the internet. If you take a look at this graphic over here, I have listed out the three major products offered by Amazon. We have the server, we have the storage, and we have the database. Once we have combined the right quantity of these products, we can package them under our company name and use the internet to provide remote access for them to our team members who may be located thousands of miles away from this specific Amazon data center. Now that we understand how this works, let's take a look at this from a business standpoint. What this means for us is we have basically no upfront costs for hardware and we're saved from the hassle of maintaining our own data centers. If you look at this arrangement closely, we don't have to do any of the servicing, maintenance, or upgrades personally. And all we have to do is we just pay a rental fee to Amazon and it takes care of all of these things itself. Not only this, we also benefit from the scale at which Amazon is operating since it's going to be having mega large data centers compared to the small facilities that we may have. Therefore, they're going to be a lot more efficient and they're going to be experiencing the economies at scale factor, which allows them to drive the cost down of working with the same number of servers that we might be using in our smaller facility. Now, this is not the only benefit that we get when we work with AWS. If we want to expand our company's IT infrastructure on a small notice of time, all we have to do is specify the resources we want and send in the order to AWS. Within hours, we can double the size of our operation without having to build new data centers or even having to wait for the delivery of new servers. As you can tell, this feature is especially important for startups that require agile scalability to match increasing use by customers. Now, the key feature is actually neither of these. The key feature is that AWS allows us to pay for exactly the amount of resources that we use. This occurs because of two reasons. Firstly, Amazon turns hardware into a variable cost by defining price rates as ratios where you're charged, say, 0.004 cents for using 1 GB of storage for 1 hour. If you store, say, 200 GB using this pricing model for 1 month, you're going to be charged about $6. However, when you go to buy a hard drive, the nearest storage available is going to be 256 GB, and this is going to be a fixed cost to you, causing you to pay up an extra 56 GB that you do not require. This is going to be true when you're going to be renting something like storage space or database space. Now, when you're working with servers, it is going to be a different deal. And this is where the second reason comes in. The second reason is something we have actually mentioned before, and it is the agility with which we can resize our deployments. If you have estimated your workload to be, say, 10,000 computations on your server per hour, but the actual usage is only about 2,000, you can quickly scale down by terminating the extra servers. If you know that during the 9 to 5 hours, you're going to be experiencing lots of traffic on your website, you can schedule that time period to have more servers to support the load and then decrease that number when the load comes down. AWS actually has an ingenious service called an auto-scaling group which does this for us automatically, and all we have to do is specify some numbers like the maximum percentage usage of CPU and the maximum percentage of RAM usage, and AWS will make sure that the usage stays below that limit. The auto-scaling group also works in the opposite direction, where we can add more servers automatically as the demand rises. So if you're looking at this graphic, in the first example, we have 4 servers that are running at 90%. What we can do there is we can add another server, and all of them will now be running at 75%. In the bottom example, we have 6 servers, which is way too many. And in that case, they're running at about 50%, which is the lower limit that we have set. And the moment we remove 3 of them, we can now boost that up to about 67%, which is a healthy range and is below our 90% range, which was our maximum. So we want to stay somewhere between 90% and 50%, and we can specify the auto scaling group, which will do this for us without requiring our input. Now, doing something like this with physical hardware is next to impossible. If you're going to be purchasing a server and then not using that server, it is going to be sitting in a corner acting as sunk cost, and you're only going to be able to sell it off at a loss. It is also going to be a problem on the other hand, where you require more servers and you estimated that you need, something like 40, and you're now going to be using 50. In that case, you have to order new servers and wait for them for weeks till they arrive, and then you can do the setup and booting and then attach them to your application. However, the on demand nature of AWS combined with the ratio based charges allows us to boot up new servers, install the required software, and attach them to the running application within a fraction of all of that time. With this, let's conclude this lecture on the basics of AWS, and let's move along to the next lecture where I'll be showing you the major components of AWS and how we plan to cover them in this course. Thank you for joining me here, and let's move along. Welcome back to this course. In this lecture, I will be introducing you to the major concepts of AWS, and the best way of understanding these concepts is to walk through how Amazon's own website uses AWS to manage its IT infrastructure. The first component of this website is the Elastic Compute Server, or EC2 for short, and the compute server is used to run algorithms, make calculations, process input, and execute appropriate functions when the user interacts with the application. For example, if we look at this Amazon screen, the recommended products that are calculated for me are actually presented from the results of a complex machine learning algorithm which analyzes my previous searches and preferences to come up with the current list. If I click on one of these products, it processes my request by redirecting me to a different page which presents more information on this product. Once I'm done looking at this, I can do a search here, which is going to allow me to submit some keywords such as Tesla, and it is going to then go to the product database and search for this specific keyword. Any titles that match this keyword is going to be presented here, and another computation will be run to look at how to organize all of the different titles. You can see there are different metrics it might use. Maybe it uses the reviews, maybe it uses how many times Tesla appears here, and maybe it uses how much revenue that specific item has brought in. You can see how important the server is, and honestly speaking, it is the brains of the whole application. Now, there's a second component of this website, which is the Amazon Simple Storage Service, or S3. The S3 service is going to act like an online cloud where we can place files such as images, videos, and documents. If you have used something like Dropbox or Google Drive, you've had experience uploading files from your desktop to a cloud and making them available to anyone using a link. It is very much the same thing here. On this page, we have lots of different product images which are being pulled from the storage devices on the AWS cloud. What happens in the backend here is when our code runs on the EC2 server, it creates a box with a link pointing to an image in the cloud. Whenever the page needs to pull up the image, it will fill in this box with whatever that is there at the end of the link. The reason why we have a separation here and why we don't actually upload the image on the server itself is because the storage on S3 is a lot cheaper than using the storage on the server. So we want to make it as less expensive for us as possible, and the way we do that is we store the character strings which contain the location of where the image is inside the EC2 server, and store the actual image on the S3 service that we have. The third and final component of this website is the database component. The database component is used to store structured data about, say, the products being sold, the sales that occur, and the basic information about a customer. The way a database stores data is in tables that follow a row and column format that is similar to Excel sheets that you may have worked with before. You can see here we have a sample Amazon table, and this table may be used to pull up all of the different sales that have occurred for the day. We have about 1,000 sales listed here, and the specific rows are going to be showing us each of the individual sales. If we scroll back up, you can see we have different columns. The first column describes the receipt number. Next, we have the customer ID. So this is going to be a unique identifier for our customer. We have the name, sale price, product ID, so on and so on. So this is going to be allowing us to run different kinds of analytics. It's also going to feed data into the logistics aspect of Amazon, which is going to decide, based on how much quantity of a specific product has been sold, do we need to ship a product from this location to another location? Is it running low? And it is going to be also feeding into the search engine, which is going to then rank the product based on how much we have sold of that product. So that's where the database sort of comes in. Database is used to store structured data, and from that structured data, you can get lots of different analytics and computations out. Now, you can see how all these three things combined work to form this Amazon website. And we actually have one more component, which is not related to the website, but it is through which we manage the whole website itself. So the way we do this is by going over to the AWS Management Console. The AWS Management Console is reached when you log into your AWS account. And here we have the three different kinds of services we talked about. We have the EC2 service, the S3 service, and the database services. So when you look at all these three services, you can basically form your application on these, and we're going to be looking at each of these in much more depth in the whole course. Now, if you want to get access to AWS, or if you want to follow along the lectures that are going to be taught in this course, what you can do is you can go over to the aws.amazon.com/free, or just search Amazon free tier, and it is going to bring you over to this page. You can go over to sign up, and you're going to be having free tier access for 12 months. And these are sorts of the limits that are placed on the amount of access you're given. And these limits are more than enough to work with anything in the course. I have made sure that any of the operations that I do are completely free, so you won't be having to pay an extra dime for any of these services in the course. Also, one thing you have to keep in mind is when you're signing up, you're going to have to submit your credit card information. So if there are any overages for the limits that you have set here, you are going to be charged immediately. And the best tool of looking at whether or not you're going over the limit, so sometimes you might accidentally leave something open, you can come down here to your name, go over to billing and cost management, and here you're going to be presented with all of the dashboard for all of the costs up till this specific month. Thank you so much for joining me on this lecture, and let's move along to the next one. Welcome to this lecture. Here we're going to be launching our own EC2 system. The EC2 system is going to be allowing us to add computation power to our applications, and you can think of the EC2 system as the workhorse which is going to be doing all the analysis and query running for us. So let's go over to the compute section. Here you can see we have the different services regarding computing in our corporation, and we're going to be selecting the EC2 service. EC2 actually stands for Elastic Compute Cloud, and Elastic Compute Cloud is going to allow us to run servers in the Amazon data warehouses and have those servers available from anywhere in the world. The reason these servers are elastic is because we can add more servers or remove servers as we wish depending on the demand for computation. In the EC2 dashboard, we're able to take a look at a glimpse of how EC2 is being implemented into our company. So you have information about statistics as to how many running instances do we have, how many dedicated hosts do we have, how many disk volumes do we have, key pairs, those sorts of things. So here you need to make sure whenever you log into your EC2 dashboard as a free tier user, you need to keep in mind that running instances and running multiple instances at the same time and leaving them unattended can cause you to have charges. So currently what is covered in the free tier is going to be you can run one system for a whole month without having any charges, or you can run two systems for half a month without having any charges. Now, if you leave two systems running and you don't take a look at your AWS console, you're going to be having problems with paying for the overage. So just keep in mind about your running instances and make sure you terminate your instances once you're done working with them. Here you can see we have something called a security group. The security group controls how we access the specific systems. So through what manners and through what ways can we access the system, add information to the system, add softwares, all of those packages to our system. And here you can see I have one security group added. And if you don't see a security group for yourself, don't worry about it. The moment you go to launch an instance, there's going to be a default security group created for you. So whenever you come to your AWS console, make sure you take a glimpse at the statistics and then go and do whatever that you need to do and make sure you're going to be running the exact number of instances that you want. So without further ado, let's go over to the create instances aspect and launch our instance. Here you can see we have what is called an Amazon machine image. An Amazon machine image, also called as an AMI, is going to be storing information about the operating system and the different applications as well as software that is pre-installed into your instance. So if you have a Amazon Linux system, it is going to have the Linux installed for us, and it's going to be having these different default software packages such as Python, Ruby, Perl, Java, and most importantly, AWS command line tools. The AWS command line tools allow us to access our server using our bash scripts that we can run from our Windows and our Mac systems. So here you can see we have lots of these packages preloaded, and this is the one that we're going to be going with. Before we move on, let's just scroll through and see a couple of the ones that we want to maybe take a look at in the future. We have SUSE Linux here. This is the enterprise server that is very often used in companies, so this might be a popular choice for you. We have a Ubuntu server. This is going to be a free server that you're able to work with, and if you want to transfer your company over from an Ubuntu server to an Ubuntu server here, you're going to be selecting the Ubuntu. We have what is called an Amazon RDS. So here in the middle you can see we have this RDS. An RDS is going to be a server that is dedicated to working on the relational databases, and the relational databases are going to be storing all the data regarding the transactions that occur in our company. So for example, purchase data, sales data, all of those things are going to be stored in the RDSs, and if you want to launch a database, you can come here and click launch. You can also see, other than Linux, we also have a Microsoft Windows AMIs. So here we have the Windows AMIs 2012s, and alongside that we have different server packages that we can choose. Here we're going to make sure that we're working with free tier only, and in this training you're going to see this over and over. I'm going to make sure that you stay in the free tier so that you're not charged additional. Here we're going to go over to select, and we have chosen the Amazon Linux AMI. In this page, you're going to be able to add the different kinds of computation power to your instance. So the computation power is going to be seen by the number of CPUs we have and the number of memory we have. So the memory is going to be measured in RAMs units. So say for example, you have say 8 GBs on a MacBook. If you have say 16 GBs, it's quite powerful. Usually you're going to be having something like 8, 16 or 32 on your personal computers. It goes all the way up to about 1952. So this is the largest that you're able to issue, and this is honestly speaking very, very powerful. Alongside that, you have different cores that you can be running, so you can divide out your work on top of that CPU itself. So these are the two measures which you're going to be using when you want to select the power that is behind your instance. The only eligible instance for the free tier is going to be the T2 micro instance, and we're going to be going over with our T2 micro. Let's go over to configure instance details. We have the details here which are going to be associated with the number of instance, purchasing, and the networks associated with that instance. So here you can see something called an auto scaling group, and you can specify the number of systems here. Now, my advice to you is you want to go with just one or two systems here, and then you want to attach what is called an auto scaling group. And basically, what this is used for is when I was discussing the elastic aspect. So, say for example, you're running your computations and you have just two systems. On those two systems, the load is 80% on each of them. And the moment you say reach 90%, you want to just add on another instance to be sure that you're able to properly manage all of the queries that are coming. And maybe in the future, the queries may exceed the limit of, say, 95%, 98%, and you want to add another instance to basically ease the load on the other two systems. If you add a auto scaling group, the auto scaling group will allow you to specify these thresholds and say, the moment we reach 90% CPU usage, please add one more instance and then continue running those health checks. And again, if we reach 90%, then add another instance, so on and so on. Also, what you can do is you can specify maximums and minimums. So usually you're going to be starting off with, say, one or two instances. So you can say, the number of instances, one or two, are going to be the minimum. And then from that, you can move on and on. Now, the auto scaling group not only works in the positive aspect where it adds on instances, it can actually remove instances as well. Say, for example, you're only using 30 to 40%, and in that case, you can say, please go back to the previous number of instances so that we're not paying for that extra usage. This is the power of Amazon. It's make showing that you're using only the amount of servers and resources that you require. That is a great plus point for corporations which want to decrease the amount of money they're spending on IT hardware and software services. So here we can manage the information about number of instances. We have what are called spot instances. Spot instances are going to be something like bids that we place. So say for example, we place a bid of $5, and if we have a high bid, then in that case, we're going to be able to get access to that specific instance. If we win over the market price, we're going to have access to that instance. And the reason for adding bids is because this is oftentimes a lot cheaper than the regular way of issuing instances. So the problem, although here, is that you can be terminated within an hour and you won't be really getting much notice, and any computations you might be running are going to be left right there, and you may have problems when you're going to be requiring sort of like a dedicated service. If you are going to be having something like you're running a web application and suddenly your bid price no longer is competitive, it's automatically going to get rid of that instance and your service is going to be down, your website is going to be down. You don't want that to be happening. So, what you do oftentimes is you specify a base number of instances, something like 4 or 5 instances. You continue those over. And for the spot instances, say for example, if you want to do some major analysis of data, you request the spot instances for a while and then you just get rid of them and you make sure that your services are not going to be impacted by the volatility of the amount of instances you have available to you. If we go over to information about network, here we can manage the VPCs, which allow us to create a secure network which we can use to share resources across different instances. For example, if you think about your home, you're going to be having many different devices and they're all connected to, say, a single internet, or you may have, a configuration where you have a single router which connects many different devices together. What you're able to do there is you're able to share information from one device to another. Maybe you're able to do remote desktop and all of those things you can do. And this allows us to have the network creation. And if you want to have advanced access to security and creating your own networks, you can go over to creating a VPC. This is actually a very, very important topic for the solutions architect exam. The subnet is going to be in the availability zone in which we want to create the specific networks. And if we want to have a specific availability zone, we can specify that. However, we don't need to worry about this. Here, are we using a public IP or are we using a private IP? We can select those informations. And here we have information about an IAM role. An IAM role is going to simplify access to our instance. So if you think about the instances we have, we're going to be needing something what is called a key, and you can basically think about it as a username password type of entry, although it's not really having any username, it's just sort of like a password that you specify, but you can think of it like that. And when you have these key pairs, you're going to be generating hundreds of different key pairs for the different developers that are inside your team for the corporation. And it's really difficult to manage those key pairs because what you have to do is for these instances, for a single instance, you may have to create different key pairs for different people. What you do here is you just say, you know what, we're going to require a couple of privileges, and any user which matches those privileges can do whatever he or she wishes with the system. And if the user does not match those privileges, then he or she cannot access the system. Very simple. You would want to use these IAM roles. They simplify access to your specific servers. Here we can specify information about the shutdown behavior. So for example, it's basically really easy to terminate your systems. You just go over and click terminate. And once you click terminate, the system is gone. And usually you might want to specify something like, I want to save the root volumes. However, your system is going to be gone, and any computations that you are running are going to be gone as well. And any services that were provided through that system are gone. So what you want to do here is you want to make sure that the shutdown behavior that you have is a stop behavior and not a terminate behavior. It's going to be automatically terminated otherwise. Also, if we click on this protect against accidental terminations, this is actually going to be like one of those notices that we get where it's going to be, do you want to terminate this? However, it's going to be a little more vigorous than that. What it says is you cannot terminate this. And what you have to do then is you have to go inside the settings, turn this specific feature off, come back, and then terminate it. So in that time, you get the idea that, do I actually want to terminate this? You get second thoughts on that, and all of those aspects. You are able to control that from that specific area. Here we have what is called monitoring. The monitoring is going to allow you to look at exactly which services are using the CPU inside my system. So say for example, you're running a website where you have two different aspects to it. So one aspect is the web application itself. So the fact that you're running the website and you're going to be processing all the queries that the customers give you. Maybe the customer clicks on this button here, you direct them to a different page, all of those aspects. And then maybe you have a database attached to it. So you have all of the sales purchases, all of those data attached to it on that system. Now, you want to understand which aspect is using what percentage of the CPU. So for example, if the database is using lots of CPU and you're having problems on the system and your specific web application is not running properly, maybe you want to transport that off to a different instance, and you can quite simply do that by looking at exactly what CPU usage is being used. You can look at memory usage. So say you're using 4 GB out of the 5 GB, how is the RAM usage being working, and all of those aspects you can look here. Obviously additional charges apply, so we're not going to be clicking on this. The last setting that we have available to us here is the tenancy setting. So the tenancy setting is going to be the information about where we're going to be hosting this instance. So if you think about it, the Amazon data warehouses are going to be having these servers stacked up in racks, and they're going to be stored there. All of the heating, cooling, the power usage, all of that is going to be managed by Amazon. Here you're basically using a couple of buttons and running this instance. Now, a single hardware is going to be able to support many different instances. So for example, if you have a Amazon machine which provides 1952 GBs of this RAM. And in that case, you can actually section that off and provide that into thousands of different T2 micros, hundreds of different T2 micros, and provide that over to different users. Now, if you want to have a dedicated system, you can go over to select dedicated and run a dedicated host, and you can click on the dedicated host systems here. Usually this is advanced information, and if you want to have security and hardware security, you can do these settings here. In the advanced settings, we have information about what is the setup code that we want to run. So for example, if we have a specific information about, say we want to install a specific software, we're going to be running some sort of a query which allows us to install that software. We're going to be running a query to update our system. We're going to be running a query to activate access to HTTPS. All of those aspects you can control from a specific text file that either you can upload or you can paste into this user data. And it basically saves you the trouble of going in and then going and hand writing all of those queries out and then having to work with it that way. Here you're going to just paste it, and automatically when your auto scaling group starts working, say you add another instance, it is going to access the specific user data, and it's going to allow you to escape the trouble of having to add that installation cycle yourself. With that, let's end this launching an EC2 instance part 1 lecture. Here we took a look at the 3 steps that are used in order to set up our instance. The first step is to choose the AMI, where we're going to be having the different software packages installed onto our instance. Next was choose the instance computation power, where we looked at how we're going to be associating the number of different CPUs and how we're going to be associating the different amount of RAM. And finally, we looked at the details of launching our instance, such as the number of instances, the payment, the network, and the shutdown behavior. Thank you for joining me here, and let's move along to the next lecture where we complete out this series on launching an EC2 instance. Let's go over to add information about storage. The storage is going to be the amount of volumes that we're going to be mounting on top of our system. So the system is actually going to be having 2 parts to it. We have the core system, which allows us to have all of the CPU usage, all of the running of analysis, and all of those computations, calculations, all of those are run by the system. However, if you think about, say, you're going to be adding 10 and 10 together, where do you get those 2 values, 10 and 10? You're going to be getting them from a specific memory. The root volumes and all of these different SSDs are going to be providing those numbers. So the 10 and the 10 are going to be processed by the CPU. So the CPU says, I'm going to add these 2 numbers together, which I get from this specific memory location. Once I get that specific result, I'm going to store that back into that specific storage location, and it's going to be storing and accessing using these SSDs that we have. We have the root volume here, and the root volume is going to be having this following path. You can access this path, and when you look at SSHing into your system, you can access your specific device by looking at this path here. We have information about the snapshot. So snapshot is going to be the restoration aspect. So if you, for example, are going to be deleting your system, maybe you want to restore specific aspects of that, you can store it onto a snapshot and then restore your system. You can control information about the size that is going to be there for your specific volume. So if you have, say, a large volume where you're going to be having, say, 50 GB on your root volume, something like that, you can attach those sizes here. Keep in mind, you are going to be restricted to 30 GB of EBS volumes. So if I add another volume, I need to make sure that both of these add up to be less than 30 GBs. If I add another one, all of these need to be below 30 GBs in total. And this is how you basically add on different volumes. So these volumes are going to be self-contained, and they're going to be able to share information with different volumes. So you might want to add volumes like this. Let's delete these. Let's look at the type of volumes we have available to us. These are the 3 basic types, and they're going to be ranked by the IOPS that are available to us. So how many inputs and outputs per second do we have available to us? So if you think about it, say we have a computation that we're running where we're going to be adding, say, 100 numbers. In that case, we're going to be able to do all of that in just 1 second, where we're able to get the input of 100 numbers, process the specific, say, computation that we're doing, and then place it back. So if we have 1,000 numbers, then that number is going to increase. So basically, the amount of IOPS we have is going to be deciding the performance of our CPU in terms of running these different analytics and calculations. If we go over to something like provisioned IOPS, this is going to allow us to provision IOPS based on our own requirements. And whenever you see provisioned, the provisioned aspect always is going to be allowing you to control exactly how many IOPS you want. If I go back to SSD, you can see the IOPS are going to be specified as 100. If I select something like 10 GBs, come out here, you can see it is still going to be 100 here. So that is information about how you can add the different volume types. If I go over to magnetic storage, this is the cheapest storage, and this is not going to be having information about IOPS. You're going to be having a different kind of indicator for magnetic storage. So these are the three kinds that we have available to us. And if you think about which one is most expensive, these two are most expensive. Obviously, it depends on how many IOPS we're provisioning. So this may end up being less expensive. But obviously, if we go and exceed over, say, the 3,000 limit, then obviously we're going to be paying more for the provisioned IOPS versus general purpose. The magnetic storage is going to be the cheapest for us. However, in this case, since we're able to choose from magnetic or EBS, we're going to go with the EBS SSD storage. In case you're wondering, the SSD stands for solid state disk. Let's go over to tag instances. The tag instances are going to be the information that you can specify about the system. So for example, you can specify a name for this system. Say the system is going to be called sys underscore 01. That is going to be the name of the system. You can specify something about, say, the manager. So who is the manager here? And we can specify something like John Stewart. John Stewart is the manager of this system. What kind of a system do we have here? So we can define system type. And the type of system that we have is, say, a quality assurance system. So this is a QA system that we have. And if you're not familiar with a quality versus a dev system, if you think about, say, a sandbox where you're able to do all sorts of practice, all sorts of different experiments that you want to run, all of that is done in the dev system, where you're going to be developing the application. And once the application is ready to be presented to the customer, it's going to be shifted over to the quality assurance system. And that is going to be the time when you make that service available to your customer. So you can add more tags like this. And basically, when you get a report of the information about this instance, it's going to say name, sys underscore 1, manager, who's the manager, John Stewart, type, this is a QA system. You can also search up this information, and when you say type, it's going to return QA. Let's go over to the last aspect that we have to configure here. And this is going to be the security group configuration. The security group here, as you can see, is going to be controlling the traffic for our instance. So it's going to be telling us and allowing us to restrict what sources can we expect traffic from. So for example, if we want to make this available in a website format, for example, we want anybody to be able to access the system, we need to add what is called HTTPS access. If you come here, you can see in many of these websites, you have this HTTPS here, and that allows us to access that specific website. We need to be allowing this HTTPS or the HTTP access to our system if we want to create a web application. So here you can click on add rule. If you know the specific port range, you can specify it here. If you want to look at the drop down menu, you can come here and say specify HTTP or go with HTTPS. There's another popular kind which you're going to be using with maybe Windows servers, and that is going to be looking at the remote desktops. So here you can use the remote desktop using the RDP here. So if you have already created one of these, and oftentimes what you do is you just create one and then just apply it to different kinds of instances that you're launching. You're going to be selecting an existing security group, but since this is our first one, we're just going to be going with this one here. Also, let's just make sure that we specify a specific security group information here. So we'll say something like security grp 01. Let's go over to review and launch. Let's make sure that we specify information about my IP, and here we're presented on this website. So here it's just going to be all of the information about reviewing. So if you have ever ordered from Amazon before, you have probably seen this screen, and you have the different kinds of products that you're purchasing. You have different aspects about those products. So you have instance types, security groups, so on and so on. And if you remember, these are all the screens that we have seen so far. We can edit these from this page right here. And since we know all of this is going to be exactly the way we want it, we can go over to launch. So here we have information about key pairs. So the key pair, as I said before, is how we access this specific system. If you have an existing key pair, you can actually apply the same key pair for different instances. So say for example, you create one key pair and then just make that available to the different instances that you have. Here you can choose a specific key pair. You can see there are no key pairs here. So we're just going to be going over and creating a new key pair. You can click on the specific key pair name, or if you want to just proceed without a key pair, you can come here as well. Let's make sure that we're going to be creating a new key pair. Let's call this key pair the access underscore key. Let's click on download key pair. You can see that the download has been initiated, and we have all the information about accessing our specific system inside this PEM file. With that, we can click on launch instances. You can see all of the different aspects are being launched, and here we have information about that we're launching our system, and we have the estimated charges, so on and so on. We're going to be seeing how we can create billing alerts in a couple of lectures. So the billing alerts are going to make sure that you're not reaching specific limits that you have set for yourself. If we go over to view instances, let's take a look at the instances that we have. So you can see our system is going to be shown here, and you have your name, instance ID, so on and so on. However, currently it's still going to be initializing a couple of checks, and you can see the instance state is running. Now, if you think about if you had to buy your own instance and launch it here, it would have taken so long. However, this is really fast way of launching instances. It's already running, and in a couple of minutes, it's going to be done initializing as well. So with that, thank you so much for joining me on this lecture. And here we saw how we can launch our own instance. I would like you to play around with the different settings available to us here. And let's move along to the next lecture. Welcome to this lecture. In the last lecture, we launched our own instance, and we had the initiation stage of a specific Amazon EC2 instance, and we specified lots of different information. You can see we have a new instance added, and this contains all the information about the name and the IDs of the system, as well as the IP addresses, all of those aspects. We added a volume to our system. The volume was going to be adding disk storage space. We added key pairs so that we can access our system. We added security groups so that we can make sure that the access to our system is going to be secure, and not just anybody from anywhere can access our system. We're only going to be specifying specific sources or specifying specific IP addresses that are going to be having access to our system. Those sorts of things we saw in the initiation stage. Now, oftentimes, what you want to do is you want to add more things once you have initiated your system. For example, in the middle of running your instance, you're going to be, say, having an increased need of having more volumes. In that case, you're going to be going over to the volumes aspect by this drop-down menus that are available to us here on the left side, and you're going to be adding a new volume. Let's click on volumes here. In the volumes, you can see there is a single volume that is running. The volume that is running currently is the root volume that we had specified when we launched our instance. the root volume was the volume upon which we have the AMI installed. The AMI is, if you remember, the operating system. So a combination of that and the software packages that are installed on top of that operating system. All of those things are being processed by our root volume here. Now, this root volume is going to be providing 8 GBs. As we said, if we want to expand from 8 GBs, we can go over to create volumes and then attach that volume over to our specific instance that we want to work with. So let's go over to create volume. Here, if I go over to volume type, we have an expanded list here. And the reason for this is because if you think about the T2 micro, lots of the different configurations and settings are not available for the T2 micro, and the throughput optimized HDD and the cold HDD are much more advanced types of volumes. And if you want to have these, you're going to be needing more advanced hardware which can support this. If I click here, you can see the minimum automatically becomes 500 GBs. Here you can have throughput information, so MB per second. Here we have 20 Mbps, so on and so on. Let's make sure we specify general purpose SSD. And here make sure that our size is going to be only 8 GBs. So make sure that you change this over, or else you're going to be charged for the 70 or the 78 GB overage that you're going to be having. So let's come over to the information about the snapshot ID. So if you see here, we have the different kinds of snapshots that we can upload. So when you're working with volumes, you can upload what are called snapshots, which are going to be storing information about what was the installed AMI on top of that volume, what was the installed softwares on that volume, so on and so on. So you can see we have the CentOS, we have the Red Hat here, PV Linux, CentOS, so on and so on, and you can specify a specific snapshot ID. Here we're going to be selecting one last aspect, which is to encrypt this specific device. So this means the volume is going to be encrypted inside the Amazon warehouses, and that is going to make sure that our data cannot be stolen from the specific hardware location itself. So with this, we can move on and click on create. You can see a new volume is being created for us, and once this is going to be created, we're going to be able to right click on it and go over to actions and then attach that specific volume to a specific system. Let me come over here to refresh. Let's see if it has been created here. You can see now it is available to us. Let's unselect this and select this volume here. Go over to actions and click on attach volume. Here we're going to be able to attach this volume to a specific instance. Let's select the instance that we're running. We have the sys_01 instance running here. This is the device information here, and we're going to be specifying information about attach. You can see we're running that operation, and we're going to be attaching that specific volume over to our instance that we created in the previous lecture. If you think about the state here while that's loading, if you saw previously the state was available, and in available state means that that volume is available for use and available for attaching to a specific instance. In use means it's going to be being used by a specific instance, and you can see all of these information if you scroll across here. Now, if I click on reload, you can see we have added that specific volume onto our EC2 system. So it's very easy to add these volumes over. Thank you for joining me here, and in this lecture we saw how we can add a new volume which is going to expand the amount of storage that we have available for our computation system, which is the T2 microsystem that we launched in the previous lecture. Let's move along. Welcome to this lecture. We have taken a look at how we can create volumes and attach them over to our instances. Now we're going to be looking at how we can create what is called a snapshot and then launch a volume based off of that snapshot. Now, what exactly is a snapshot? You can treat it sort of like a picture that you take using a camera. Now, here we have a specific volume. This volume over the time is going to be accumulating data. It's going to be having different configurations that we set. For example, we have the encrypted configuration here. It's going to be having the different settings that we set. It's going to have different installations of software onto this volume, so on and so on. Now, when we go to take a snapshot, it's going to take all of those settings, all of those configurations, all of that data into account. It's going to replicate that data. It's going to copy that data over to a new data location, and it's going to store that as a snapshot of that volume. So in a specific point in time, it's going to store that volume's information. And the way that you will be using the snapshot is, say, when you want to launch a volume that is supposed to act sort of like the previous version of the new volume you have. So for example, you want to restore back to a previous version, you can do that. If you want to create a template volume, you can also do that using this snapshot. So you do all of your configurations, all the settings that you want, and all the basic data that you want to specify to every single volume that you might be creating. Create a snapshot of this, and then create the volumes using those snapshots so that all the information is preloaded. Let's see how we can create a snapshot in the snapshot section here. Let's go over to create snapshot. And in the create snapshot, we're going to be looking at the specific volume. The volume that we're going to be working with is the EEA2B volume. This was the additional volume that we had added. Let's specify a name for this snapshot. We're going to say something like snapshot underscore 01. Description, let's just copy this over. And here we have our snapshot information. You can see the encrypted setting is automatically picked up from that specific volume. So this is the volume that we had added on afterwards. The root volume actually does not have automatic encryption. You have to go ahead and download some sort of software which is going to allow you to do that encryption for you. We can go over to create. You can see the creation is processing, and we have completed the creation of our snapshot. The reason this is so fast is because currently we don't have much data inside our volume that we have created, so it's going to be completing really fast. However, the first time you create a snapshot, oftentimes it takes a lot of time, so it's going to be transferring over all the settings, configurations over to a new location, and that's going to be taking time. Over the process of working with your EBS volumes and snapshots, you're actually going to be updating a specific snapshot with more settings that have occurred inside that specific EBS volume. For example, if there has been a change in the EBS volume, you can update your snapshot, and in that case, it's only going to be changing the values and the settings that have changed in your EBS volume, and the amount of time it takes at that point is going to be a lot less than the initialization time. However, here it took a very small amount of time since we had basically nothing to copy over. Now we have created our snapshot. If we want to create a volume using this snapshot, it's quite simple. We go over to actions, go over to create volume. We can actually create an image as well. So if we took a snapshot of the root volume had the OS installed, it had the packages installed, it had the software installed, and we could create our own AMI, which we use to then launch the instances. So we can launch a T2 microsystem using the AMI that we create. So that is a very, very powerful tool, and we can sort of create templates and then use those templates to launch our own systems. We'll be seeing that in a later lecture. For now, let's click on create volume. Here you're given information about the snapshot ID. So this is the snapshot ID we'll be using in order to create our volume. We have the general purpose SSD volume here, 8 gigabytes, availability zone. This is one thing we did not touch in the previous lecture. Let's just explain to you what this is. So if you think about what Amazon does, is Amazon is going to be spreading out all of its different data warehouses into different regions. So we have a West region in the US, we have other regions in the US as well. Currently, I'm using the Oregon region, and you have California, all of those regions available to us. In those regions, you're going to be having different availability zones. Availability zones are actually the real data warehouses that are there. A region is basically sort of like a theoretical grouping of those availability zones. It's not a real thing. It is just a grouping of that so that you can understand, oh, I'm storing in this region, so that it's going to be providing me all of the services for this region. I should use this specific region and store all of my instances there. The availability zones are the real data warehouses that are working behind. So if you specify, say, 2A every single time, if 2A fails, all of your data is gone. So if you want to store backups of the disk that is in 2A, you would want to store it in 2B. You want to spread it across different availability zones and maybe even spread it across different regions, so on and so on. Here, let's go ahead and do the creation. Volume successfully created. Click close, and let's go over to our volumes. In the volumes, you can see the new volume is available. Now, this volume we can remember to attach to our specific instance that we have. Let's go over to attach, click on instance, go over to attach, and you can see all of these 3 volumes are now being used by our instance, and we have one root volume and we have these 2 more volumes that we have added on to our instance. So thank you for joining me here on this lecture. We saw how we can create what is called a snapshot of our volume, which allows us to copy over all of the information stored on that volume. And then what we can do is we can launch more volumes from that information, and it's going to create replicas of the volume that we have used to create this template. And we can use that to have a backup or restore back to a previous version or launch more EPS volumes based on the information that is there on the snapshot. So thank you for joining me again. Let's go along to the next lecture. We have seen how we can create security groups when we were working with launching our instance, and we saw how we can add the different sources of inbound traffic and outbound traffic. Here, let's dive a little more in depth, and we're going to be looking at how security groups can serve sort of as templates for launching the security configurations for many different instances. Here you can see we have different security groups available. So if you want to work with an existing security group, you can just click on it, go over to inbound, outbound traffic, and add information about tags. Here we're going to be creating our own security group. In the security group name, this is going to be the group that this security information is going to be belonging to. We're going to be calling this web_app. The description is going to be web application security group. Let's define the VPC. The VPC is going to be the default VPC that we have. And here we have the security group rules. The inbound rules are going to be specifying what sources can come and get access to our data. So if you think about, say, running a web application, in that case, the sources are going to be basically any user who has an internet connection, and he or she is going to be using the HTTP or the HTTP service to get access to our specific IP address. So if we have a web application, we need to make sure we add something like a HTTP and an HTTPS connection. Let's add another rule here. Go over to add a HTTPS connection this time. It's right here. And these are the 2 types that we're going to be specifying for the users that are going to be accessing this information. If we go to the source means that this is going to be anywhere, meaning any user anywhere who has an internet connection is able to connect to our specific server. If we go over to custom, now we can specify a specific IP range, which is going to allow us to specify what customers are able to access this specific server. If we go over to my IP, only my IP is going to be able to access this specific server. So here we're going to leave it as anywhere, since we want anybody to be able to access this. Here for the HTTPS, we'll also leave this as anywhere. Here anybody is going to be able to access this specific server using the HTTPS service. Let's add one last rule. This is going to be the SSH rule. The SSH rule allows us to access this specific server using our command line. And the command line is a very, very important tool and a great way of installing service packages and working with moving around resources and attaching resources to our specific instances that we may have. So here we have added a SSH inbound. This is the specific port range. And what you can actually do is, instead of going down this drop down menu, if you have the port ranges memorized, you can just paste them here and you're going to be able to look at the specific port ranges, and then it's going to catch the type that you're trying to specify itself. You have the protocol information, and finally for the SSH, as we were saying, we have different information. So here for SSH, I want to make sure I have my IP as the selected IP. So this is the IP that I'm going to be able to work with when it comes to SSHing into this specific system. There's one more aspect we have to configure, which is the outbound traffic. So usually there is no problem when you come to outbound traffic. So outbound traffic means this is going to be the sources coming out. What sources are you able to display? So you should be able to display to all traffic, and usually this is not a problem. But if you want to specify something like HTTP or HTTPS, meaning that only the web application is going to be displaying information, in that case you can do that selection here, but we don't need to worry about that for us. If you're wondering, all traffic is actually a setting available here as well. So if you go down to all traffic, see where it is, it's right here, and it's going to allow you to basically have the same settings as the outbound traffic. Let's revert back to our HTTP. Let's go over to create, and you can see we have created our new group. Let's actually rename these groups here. So this is going to be our web underscore app underscore 01. So what you can use here is the group name will sort of allow you to group many different security groups under a specific group name. So if you have web app 01, web app 02, web app 03, so on and so on, inside the specific group name here. So you can use the web app group name, and you can basically create a hierarchy where you store more of these web app 01, 02 underneath that. For this security group, we can do that as well. So here, this was our instance security group. So this is instance underscore 01. And this is our default security group. So we're going to be typing something like def underscore 01. So with that, we have created a security group for a web application. Thank you so much for joining here. And this security group will allow us to create and launch instances with the specific security settings that we have set for this security group. And it's going to be allowing us to tightening the access to our servers to make sure that we have as much security when it comes to providing access to our servers to different users. Let's move along. In order to be able to store data in a structured manner, we need to use what are called databases. There are many different types of database services that we can use with AWS. You can see we have the RDS service, the DynamoDB service, so on and so on. And before we move on to these database services, I'm going to be giving you an overview of how a database works and what a relational database is. If you already know these, you can easily skip over this lecture and go over to the launching an RDS instance, and there I'll be showing you how you can launch your own relational database. For now, let's go over to the PowerPoint here. On this PowerPoint, I have a single table, which is the sales table. This table is going to be having two different structures. The structure which goes vertically like this is called a column, and the structure which goes horizontally like this is called a row. In this table, we're going to be storing all the sales that occur inside our company. And the first sale is going to be given the first row here. The second sale will be given the second row here. The third sale will be given the third row, and so on and so on. So as we move along and make more sales for our company, we're going to be adding more and more rows to this table. And when you're going to be working with large corporations, you may have millions of rows that are going to be describing the sales, the purchases, and the transactions occurring in that company. Now, the columns which are going to be here are going to be describing each of those rows. So say we had one row here where we had a specific sale that we made to a customer. We need to be able to describe the receipt. So what was the receipt ID that we gave to that customer, who was the one making the sale, which sales organization made that sale, the customer ID so that we can pull up the specific customer's name, information, shipping information, and all of those cases, the material ID as to what material are we shipping, the quantity, price, and the date on which the shipment is to be made. So all of these are going to be descriptions that describe a specific sale that occurs inside our company. And the columns are going to be storing those descriptions. Now that we have an understanding of how a basic table works, let's move on and see how relational databases work. In a relational database, what you'll be having is you'll be having these different kinds of tables floating around. So you may have, 10 different tables. Now, for those 10 tables, you may have connections that can be drawn between two different columns. For example, here we have a common example where we're going to be having a center fact table. The fact table is going to be storing all the transactions that occur. So here we said a sales table is a fact table. And we may have a dimension table, which stores information about materials. These are not sales that are occurring. These are not transactions that are occurring. These are the materials that we have inside our company. This is relatively unchanging data and is going to be stored in dimension tables. Now, in order to be able to refer to a dimension table, we have what is called a material ID column. The material ID column in this table refers over to the material ID column in this table, and if we want, we can easily click on this number and it's going to direct us here, and we can pull up this whole row like that. So what is the reason why we do all this? The reason is because, say we have another fact table. In that fact table, we can again draw that link over to this dimension table. Now, if we did not have these linking structures, we would have to copy down this information for each of these fact tables, and that would obviously not be efficient. So let's go down a little more. Here you can see I have another connection that is being made. So this is the second dimension table here. The second dimension table is going to be storing information about all the customers that are associated with our company. All these customers are going to be related to this transaction table, which is the sales table, through the customer ID information. So here we have a customer ID. When we go over to 9482, we can be forwarded to this table and then look at the specific street addresses, the city, the country, the name of the customer, so on and so on. Let's go down one more time. And here you see we have one more table, which is the sales org table, which is going to be describing the sales organization which has made that sale. Now, one thing you will notice is in this table, we basically have numbers, and all of these fields are going to be numeric fields. Why is this so? The reason is because all of these are basically going to be IDs referring over to different tables. So the customer ID refers over here, and then this customer ID here is associated to all of this text here. The numeric data is going to be very easily replicated over here, and it's very efficient to store this numeric data. So you're going to be having all of your IDs in this transaction table. This transaction table's purpose is to associate all the different IDs together, and whenever we need specific information, we can just go over, track this relation, and come over to the dimension table. So this is basically how relational databases work. You're going to be creating these separate tables, and then you're going to be relating them together as you wish, as the application requires you to do. So that's how a relational database works. Let's move on to the next lecture where we take a look at how we can create our own relational database. Thank you for joining me here. Let's move along. Now that we understand how a relational database works, let's go over and launch our own RDS instance. This is the page you're going to be shown when you launch your first instance. You can go over to Instances and go over to Launch Database Instance. We have many different providers when it comes to selecting a database engine. The first provider we can see is Amazon Aurora, and Amazon Aurora is actually an enterprise solution, so it's going to be used for managing large databases. It has the scaling capabilities, and it has the retention and the reliance of a enterprise database. What this means is it's going to be competing directly with Oracle. And the reason why it is so effective in competition is because it provides basically the same services as Oracle, however, at about a tenth of the cost of Oracle. So that's why Amazon Aurora is a very, very competitive database, and it is launched through AWS. And many companies are going to be switching over to Aurora as they see this option coming up for the AWS platform. We're going to be going over to MySQL. On MySQL, we have a open source database. So MySQL is going to be a free database that does not require us to purchase a license to it. And that is the reason, obviously, why we're going to be selecting this when we launch our database engine. And the fact that it's free does not actually restrict the capabilities of MySQL. MySQL is actually a very, very powerful database, and that is why it's used all throughout the world by different companies. And when you're going to be looking at migrating databases over, many times you're going to be presented with MySQL databases. We have different kinds of databases here as well. We have MariaDB, PostgreSQL, and of course, we have Oracle. Oracle, we have different kinds of licenses. So we have the Enterprise Edition, Standard Edition, and the different kinds of editions. These are obviously going to be priced at different rates, and we can select the one that we're looking for here. Lastly, we have the Microsoft SQL Server. Again, we have different kinds of editions available to us. First, as we said, we're going to be going over to MySQL and clicking on Select. So it's going to be asking us, do we want to use this database for production reasons? And here we're actually going to be going over to the test and clicking on the next step. Now you can see we have information about the instance. This is a MySQL instance that we're launching here. And if we go over to license, we have the general purpose public license here. This is the free license that is available for MySQL. Now, when it comes to working with licenses, if you have already created or purchased the licenses from different services, you can actually import those licenses onto your database instances, and you can start using those licenses here. You don't have to purchase them again. And this is obviously a case for many, many different companies. They may already have licenses for 5-6 years. However, they may need to migrate over to AWS and they don't want to repurchase the licenses. Before we move along any further, we're actually going to restrict all the options so that we're only working in RDS free tier. We have now the ability to choose different versions. So when you're going to be importing from a different company and when you're going to be migrating a company's databases to the AWS platform, they're already going to be having a specific version here. Now, you need to first check whether or not you can go over to the higher versions, because oftentimes these higher versions have not been tested as much. They're not reliable as much as the previous versions here. And you need to make sure that your data and your structures are going to be compliant with any of the versions that you select. So you need to make sure, firstly, you import into the same platform and the same version as the version you have inside your company, and then you can escalate that up and you can upgrade them over to the newer versions. We're going to leave this as the 5.6 version here. Let's go over to the DB instance classes. You can see we have the T2 micro and the T1 micro instance classes. Hopefully this rings a bell, where if you remember when we were working with the EC2 instances, we had different kinds of instances that we could launch. We had micro instances, we had micro instances, small instances, large instances, those sorts of things. If I actually untick here and go over to instance class now, you can see all of those other kinds of instances that we had seen before. And basically, if you think about what a database instance is, it's very similar to the servers that we were launching, except the fact is we're only going to be running the database services on that server. So that server is going to be dedicated only to running a database. Let's come back and go to the T2 micro instance. We're not going to be working with multi-AZ deployment. Multi-AZ deployment is basically when you spread out your database into different availability zones. This is done so that, let's say you have some sort of a disaster In that case, you're going to be able to recover at least some parts of your database. And if you have worked with storing backups correctly, you may be able to construct your database completely together. We'll be going with the general purpose SSD, going over to 5 GBs of storage. Let's define some information about identifying this database. Let's type db-01. You need to make sure you're going to be staying within the namespace that is allowed for the database instance identifier. So anything like underscores and any other characters are not allowed. You can only use the characters, numerics, and the dashes. Here, let's specify a username. A common username for MySQL databases is root, and you can give your own password here. I'm going to be defining one for myself. Let's go over to the next step. Here we have advanced settings, so we can define the network and security settings. You can see as we move along, a lot of this is very much similar to the servers that we had launched before. We're going to be going with the default VPC. We don't want to spread it over to a different availability zone. We don't really care about which availability zone we're using. Here you can specify the publicly accessible or not publicly accessible. So what this means is what is the access traffic inbound that is allowed. So here you're going to leave this as yes. And then we can add the restrictions by creating our own security groups for these database instances. Let's leave this as no preference. And here, instead of creating one own, we're just going to be going with the default VPC. Let's go over to the database name. Let's again call this db-01 and the connection parameters. Finally, we have these three sections where we can specify the backup retention periods. So it is very important to be taking backups of your databases. If you have a backup retention period of 7 days, what that means is you're going to be having, say, a disaster on the 7th day. All the data for days 1 through 7 is going to be destroyed. However, any data before that is going to be saved in the backup, and then you can back up your system to that specific day. If you want to specify a specific backup window, you can specify this as well. This is going to be having automatically scheduled backups, and you can specify them as the start times and the duration for how long the backup goes over. Finally, we have enhanced monitoring, because here too we're going to be having CPU usage and memory usages. You need to be making sure that you're controlling them properly so that you're not going to be overloading your system. And if you have a specific type of query or a specific user who's causing a problem with the system, you can go and tell the user, or you can restrict those here by taking a look at what is exactly occurring inside your system. Here we have information about maintenance. It is important to be able to initiate upgrades, and here if a new version comes along, it is going to automatically do a version upgrade. Many times you might want to go with no, and the reason here is if your data is very much sensitive to the kind of structure that is provided by a specific version, you don't want any sort of upgrades occurring automatically. You want to first test that upgrade on a dev system and then apply it to your QA systems. Here we'll just go with yes, and we're going to go over to launch database instance. Let's make sure we have the specific name here, make this underscore, and go over to launch database instance. Thank you for joining me here, and let's move along. Welcome to this lecture. Here we're going to explore a couple of these properties that we can associate with our S3 buckets in more depth. In order to do that, we'll go down to the home page, and here we're going to come down to properties. In the properties tab, we're going to be looking firstly at the static website hosting. Let's click on this. What this allows us to do is it provides us an endpoint through which we can submit a HTML page and allow users to have access to that page and therefore access to our content. So if we enable web hosting, it's going to ask us for an index document. An index document is going to be an HTML document which has the links as well as the interactive code that we might place there, such as buttons and those sorts of things there. So here I'm going to be pasting the welcome.html page, and I'm going to be hitting save. If I click on this, it's going to bring me to this page. And if I click on one of these links, it's going to download the content associated with that link. If I click on getting raw data, it is going to display it. Since it's a simple text document, we have all the data sources here. And if we click on cleaning and filtering data, it is going to be a practice sheet. So it's going to be opening up that as a download. Let's come back. So this is a great way of pulling up a simple website which is going to allow access to the content that you have stored in your bucket. We're going to hit save, and we're just going to close the static web hosting. Let's come over to logging. And logging is actually a very powerful tool which allows us to track the changes that are occurring in our bucket. We're going to be enabling logging, and this is going to be enabled on a different bucket that we create. So let's come out of this, and we're going to go to all buckets, create new bucket, call this the logging bucket for LMS 1001. We're going to hit create, and we have created this bucket. Let's just copy the name here, come back to our sales bucket, go over to properties, and come down to the logging, enable logging, and paste in the bucket name. This is our bucket right here. So what this will do is it's going to be creating this folder, and it's going to be submitting all the text documents in the folder, and after 24 hours it's going to start the logging process of whatever changes that occur inside this specific bucket. Let's hit save, and we have enabled logging on our company sales LMS bucket. Last thing we're going to be looking at in this lecture are events. Events allow us to send alerts and execute certain functions when a certain event occurs. For example, if a file has been uploaded, we may want an alert to be sent to us, or if a specific HTML document has been uploaded or deleted, we want a system-wide check to make sure everything is working fine, and we could have what is called a Lambda function execute that check. So those sorts of things can be managed through the creation of events. The way we create these events is we specify a specific event name. So here we'll do something like creation of object. We can specify the event that has occurred. So here we're going to have either an object has been created or an object has been removed. If you go to specific ones of these, you can do that as well. So here we're going to be looking at the object created. This is going to be a prefix. So what prefix do we want when we send it? Here's a suffix, what kind of a object has been created. And here we're going to be specifying to which application do we want to send this alert. So if we send it to the SNS, this will be sending us a notification of the alert. If we send it to the queue system, this is going to queue our request for a specific change inside the SQS queue. And if we send it to the Lambda function, this is going to be executing a specific function. And actually the Lambda functions are really, really versatile, and they can be used very dynamically in the sense that the moment you specify a specific amount of code, that code will automatically provision the resources, provision the billing. It is going to get started and execute that action without you having to do anything. You just give the code over and the Lambda function will execute. In this case, we're just going to click on the SNS notification, and I'll be showing you how you can create a couple of these kinds of alerts in a later lecture. Let's put something like images here, and we'll just put in JPG. So here we're going to leave this as SNS, and actually we're going to be coming out of this since we have not seen how we can create SNS topics. But once you see how to create those topics, you can easily create these events and associate them with your buckets, and every time a change occurs, it is going to be either sending you a notification, queuing your requests, or executing some sort of a function. Thank you for joining me here, and let's move along to the next lecture. When it comes to working with databases in AWS, relational databases are not our only option. We can also use what is called DynamoDB, which is a NoSQL database created by Amazon. Let's figure out how NoSQL works, and then we'll be implementing this into the creation of a new table in DynamoDB. Let's come over to our PowerPoint slide. So if you remember from our relational databases introduction section, there we worked on this central table and we connected these auxiliary tables which are going to be providing us extra information such as customer name, street, city, country for the customer aspect of the central table. These tables were connected together by these joins that we formed, and these joins were architectural components of the whole database where they formed relations between different tables. When working in NoSQL, we don't have these joins. These joins actually restrict us from scaling our database up. And the reason here is because every single time we want to expand our database, we're going to have to recalculate the logic that goes behind adding these joins. And we're going to be having to spend a lot of time and resources when it comes to increasing the size of our database in accordance with the amount of data that we have. If we're going to be regularly increasing the data, then this can become a very inefficient process. If you don't have these joins, as we don't in NoSQL, in that case, we can increase the scale of our data as soon as we can section off the hardware for it. So we don't have to wait for the recalculation of these joins and the logic creation that goes behind the relational tables. The way NoSQL works is it's going to be storing each of these tables in a different document. So when you have these different documents, you're going to be having all the data stored in a single document, and there are no joins which are connected here. What you can do is you can store multiple of these different tables in what is known as a collection, which is not an architectural component, but more of a semantic component, which is going to be grouping together related data. So you can quite very simply change the collections, and there's no sort of join recalculation that you have to wait for or do manually. When you're going to be scaling your tables, you can just add another table which is going to be holding or continuing the previous data that we had. All of this is going to be coming with a decrease in functionality when compared to relational databases, because we're not going to be able to restrict the specific data types for columns, since we don't have any columns in these cases, and we're not going to be able to restrict the numbers of characters that we can store. All of those cases are not going to be available to us when working with NoSQL databases. So there is sort of a increase and a decrease, a positive and a negative side of working with NoSQL databases. You do get agility and scalability, however, you have to let go of some functionality that you were able to have when working with relational tables. The reason for working with NoSQL is going to be whenever you're going to be implementing big data solutions inside your company. With big data, you're going to be scaling all the time, and your data usage or your data collection is going to be increasing over time. In order to keep up with this, you need a system which is going to be very fast when it comes to responding to the data amount flowing in, and a system which can scale very quickly. So with that in mind, let's go over to the creation screen of DynamoDB. Let's go over to Google and come down to DynamoDB. Here, we're going to be going over to create table. The table name we're going to be specifying as a customer. Let's define a primary key. We're going to be having the primary key as a customer ID. This is going to be an integer field. So let's go down to integer. And here we're going to be going to create. As you can see, it is very easy to create these DynamoDB databases. Here we are going to be creating this table, and once the table is created, we can add what are called items, and we're going to be adding multiple items which serve as the records inside our tables. Thank you for joining me in this lecture, and let's move along to the next one, where we see how we can add data to our DynamoDB. Welcome back to this DynamoDB tutorial. Here our customer table has turned active, and now we can click on this and start working on the information that is associated with it, as well as adding a couple of lines by hand. If you see here, we are on the overview tab. Here we have some information about our table, how many bytes of storage size we have, how many items we have stored here, so on and so on. Let's go over to items, and currently we only have the customer ID as a specific column. We're going to be creating a new item by coming over to create item, and this is going to be a single row that we store. So let's specify the customer ID number. I'm going to do something like 1001. Come here, do an append, and here we're going to be adding a first name. So do fname, and here we're going to be having John as the first name. Do another append string, and here we're going to be having an L name, and here we're going to be having Stewart as the last name. This is all we're going to be specifying for this person. Let's hit save, and you can see we have specified the customer ID, first name, and the last name. Now, this was quite simple. We didn't even have to specify the schema for the table, so we didn't have to say we're going to be having first name of this specific schema, of this specific kind of data, and of this specific length. We automatically added this information, and the specific data types were calculated from the data that we inserted into that specific field. We can actually create another one of these items. Let's go over to create item. Here we're going to be typing in the number as 1002. Let's append one more, and this time we're going to be appending the first name. So here we're going to be having fname, and this is going to be Melissa. Let's add one more. This is going to be L name, and this is going to be Jones. Now, there are lots more data types that we can add. We have the binary data types, numbers that we can add. Let's select a Boolean data type here. So we're going to select something like prospect. So is this person a prospect for sales? And here we're going to put something like false. So here we have added a new column. Let's go and hit save. You can see very easily we can add new information to the table structures, and you can see why it is so powerful when it comes to scaling data. For example, when you have unstructured data, you may have many different kinds of columns. Many of these missing values may be there, so on and so on. And you may have to update the table schema to accommodate for the data that is coming in. That is called unstructured data, where you don't have data from a tabular format coming in. When you have unstructured data, your data types of columns are not going to be set. The data columns themselves are not going to be set, and the table structures are not going to be set either. Here you can very easily and dynamically add more columns and add more data types to the existing table that you have. Now that we have added these two, let's move on to the metrics aspect. In the metrics aspect, we have the key metrics which are used to understand how our database is working. So these metrics are going to be explaining to us information about the read capacity and the write capacity. These capacities are going to be very important when it comes to the understanding of how you're going to be billed, and also understanding how much of this database is being used. So the load of the database you can understand from the amount of requests that you get for read and the amount of requests that you get for writing. In the bottom here, we have latency. So latency is going to be how much time does it take for the database to respond. If you want to provide a low latency service, which you want to do regardless of whether the customer is going to be accessing or whether it's a business user, you want to provide the lowest amount of latency. And for that, you need to be managing your CPUs and information like that. So you need to attach more instances possibly, or expand the size of your database. All of those things you can understand from these metrics that you have here. Now, there's one thing that we didn't see, that was the get information and the reads. So let's actually come back to items, and let me show you how you can sort of search for the information here. And this is a similar way from the API, how you're going to be allowing access to the data. So here, instead of scanning the table, we're going to use query. The query aspect is something that is from SQL, and using the information about the customer ID, which is a unique primary key, we're going to be giving something like 1001. I'm going to do a start search, and you can see we have 1001 appear here. We have the customer ID come up like this, and we can click on this and we can take a look at this item. If we just leave this item as is, this is going to be a read. If we edit the item, then we're going to be writing to this specific database. Let's take a look at one last aspect, which is going to be creating alarms. So you can do what is called the creation of an alarm. What this does is it's going to be allowing you to add information about how many read capacities are being consumed, and if the read capacity goes over a specific limit, then it's going to be alerting you and telling you that, hey, there's a problem here. Maybe somebody is overusing or overextending the resources that we have. We're going to be billed a large amount for this, something like that. And you can create one of these topics, and you're going to be sent an email regarding this. And here you can specify information about what limit you want to set, and you can specify about how many consecutive periods are required before this is sent over. So if you see here, you can say for at least one consecutive period of 5 minutes, for 5 minutes straight, we have been having a overage of say 10 or whatever thousand, how many capacities that have been used. So you can specify all those alerts here, and it's going to be sending you an email whenever something like that happens. So thank you for joining me here. Hopefully you understand how DynamoDB works and how we can add new data over to our DynamoDB tables and how we can search here. Thank you for joining me, and let's move along. Welcome to this lecture on creating an S3 bucket. An S3 bucket is sort of like a folder on the cloud where you're able to upload files and have them accessible to other people by specifying a URL. If you have heard of services such as Google Drive or Dropbox, this is very similar to that, where you're able to upload basically any type of file, whether it be a video file, a text document, HTML document, or a image. You can upload it there, and there's a specific URL that you get. This unique URL you provide to anybody, and they can access that specific content. Now, you might be thinking, why is this so much different from the volumes that we have in the EC2 servers? The reason they're different is because the volumes that we use for EC2 are used to serve the server itself, and any sort of computations, any sort of information that the servers generate is stored on this volume. Another way that these volumes are used is that any sort of information that the EC2 servers require over and over again is also stored on these volumes. Let me walk through a use case of these S3 buckets. A common use case is the development of a course which is sent out to a employees, development of a course which is sent out to the employees of a company. For example, you want to instruct your employees in the business aspect, and you want to show them how you can increase the amount of sales that they're creating. Now, in order to do that, you're going to be recording, say, a couple of videos, and you're going to be having text documents, you're going to be having different sorts of case studies that you have. You're going to be packaging all of that in a single S3 bucket, which is going to be having information about the different sections of the course. So you're going to be dividing that bucket out further into folders. You're going to be having section 1, say, introduction. Introduction is going to have 4 or 5 videos where you introduce them to how they can start getting more sales, more conversions. Then you have your different sections, and you start building them on and increasing their skill competency that way. So in order for them to be able to access this content, you're going to be distributing the link to this S3 bucket on your EC2 backed web application. So you have some website that's running, and that website is going to be having a connection over to a S3 bucket which provides it all of these videos. Now, it is not wise to store these on the EC2 volumes that we use, because the EC2 server doesn't really care about these videos. The EC2 server is not using these videos to do any sort of extra analysis, and it is only going to be an extra load on the EC2 server. Also, the EC2 volumes are a lot more expensive than the S3 buckets that we have. So S3 is a very cheap way of storing data inside the cloud. That's why we use the S3 buckets. And with the way that the EC2 server is going to be working is it's going to be storing not the videos, not the content, but the links of the videos and information about how to access the content. And once the user asks the EC2 server to deliver that content, it is going to access that specific link over from the S3 server, and it's going to bring that over from the S3 bucket and deliver that over to the user. That's how the content delivery is going to be structured in AWS. The EC2 systems are going to support the web application, which is facing the user. The user requests something, the EC2 system goes over to S3, and then S3 provides that over to the EC2 system, which provides it then to the user. So with that explanation in mind, let's move forward and take a look at how we can create our own S3 bucket. I'm going to click here. It is very easy to create this bucket. We will just go over to create bucket. We need to specify a universally available bucket name, and here we'll do something like company, sales, LMS, team 1001. We'll leave the region as Oregon. You can specify whatever region you want, but it is advised to keep the region closer to the customers or the users. So for example, if your team is going to be residing in Oregon, you store it there. If they're in California, you store it there. If they're in England, you're going to be finding the closest one as Ireland, so on and so on. So let's go over and click on create. We have created our new bucket. Here we have different sorts of tabs, and we'll be visiting each of these tabs in much more detail in a later lecture. For now, let's just look at the permissions aspect, and then we'll see how we can create folders which allow us to section our bucket into different parts. So here, currently, this is only available to me. I'm going to add another person who this is going to be available to, and this is going to be to everyone. Now that is available to everyone, we're going to go over and select the view permissions. And here we're not going to be selecting edit permissions. If we have something like a interactive document, in that case we may want edit permissions, but here we just want view permissions. Let's go over and hit save. We have saved our permissions, and now we can enter into our bucket. Bucket is obviously currently empty. We will go over to create folder. Here we're going to be creating something like section 1 introduction. Let's have another folder, and this is going to be section 2, and this is going to be something like lead generation. Add one more section, and this is going to serve as section 3, and this is going to be about how to convert our prospects. Let's enter, and here we have sectioned off the bucket into 3 different parts, and in the next lecture we will see how we can upload different content into these buckets. Thank you for joining me here, and let's move along. Welcome back to our discussion on S3 buckets in AWS. In this lecture, we're going to be uploading some files into a folder that we created in the previous lecture. Let's click on Introduction. Here, we're going to go over to Upload. Let's click on Add Files. And here we have the files that we're going to be uploading for our students. So you can see we have a variety of files here. We have a text file on the top, CSV file next, a Excel file, and here we have a compressed version of all of these files here. We have a TREC file, which is a special kind of recording file, which is not usually supported by many systems, and it is very much different from the regular MP4 and AVI files. And finally, we have an HTML file. You can see where this is going, since this HTML file is going to sort of serve like a welcome page that we can throw up the moment the EC2 system transfers over control to the S3 bucket. Now, when we look at the welcome page, this can have the links out to each of these resources, and the user will be able to then access these resources from this welcome page. Let's click on all of these and then click open, start upload, and you can see most of these have been uploaded. The last one is going to be uploaded in just a moment, and all of these have been uploaded to our bucket. Scroll up a little and get rid of the transfer screen. So here are all of our files. If we want to access one of these files, we click on welcome.html, go to properties, and go over to link. Now when I click this link, you can see the access denied aspect is coming up. The reason here is because even though we allowed the permission of working with viewing the bucket, the permission is restricted to just viewing the contents of the bucket, viewing the storage amount of the bucket, viewing information about the content stored in the bucket. However, you cannot actually download or open any of this content. All of this content can only be opened by the default grantee, which is the account through which you're uploading these files. If you want to add more permissions, such as the download and the open permissions, you have to click on add more permissions. Click on everyone here in the grantee and go over to open/download. Click on view permissions. And if you want to have edit permissions, you can have edit permissions there as well. Here, we're going to click on save. Now, if I click on this public URL, you can see we're presented with the page, welcome to this sales course. Now, what does that mean for you when you're uploading thousands of files? When you're working with a lot of these files, you're going to be looking at how you can upload them programmatically through the SSH aspect. When you're going to be SSHing these files in, you're able to define information about permissions, and all of those categories can work without you having to hand assign these permissions. There are other ways of working with this as well, but you don't need to worry about that here. Here, we just want to show you how the basics of S3 buckets work. So with that, we're now able to access this specific HTML file. Let's activate the access for one more file. Let's unclick this, and let's see how we can download these files. So here we're going to go to add more permissions, go to everyone, and click on open/download. Let's save. Let's click on this file here. Actually, let's go over here, and you can see this file is now going to be downloaded. If we click on this file, it is going to open up the data that we have in the file, and then we can start working with the data and save it as we want. So thank you for joining me on this lecture. We took a look at how we can upload and download files to our S3 bucket. Let's move on to the next lecture now. Welcome to this lecture. Here we're going to be looking at the versioning property that we can add to our bucket. Let's go over to properties, and here we're going to be activating versioning for our bucket. Let me explain to you what versioning does. Versioning allows us to store different versions of a file over time. What this means is, for example, if you're developing code and you have developed a working example of how your code should look, you will upload this code as version 1, and then you will do any further modifications and advancements of this code and then store that as version 2. Anything else you want to add, you store that as version 3, 4, 5, so on and so on. Now, if say version 2 fails, you can go back to version 1, since you know version 1 worked and any changes you have made has caused that code to fail, and you can just revert back those changes by going back to version 1. You can do this basically for any of those versions till you get to a single working version. This is what versioning allows us to do, and not only is this applicable to code, if you're working with files where you have overwritten the file on accident, you can come back and revert the file to the previous version, and it's going to be restored, and any problems that you have made are going to be fixed that way. Now let's click on enable versioning to enable this specific setting. Click on OK. And now we're going to be coming over to the welcome.html to take a look at how this works. Let's come out of the properties. Let's reload the page one time. You can see two buttons are going to be appearing here. We have a hide button and a show button. If I click on the show button, you can see we have all of these versionings which are going to be shown to us. Currently, we have only one version available for our welcome.html file. And if we want to see how versioning works, we will make some changes to the original file. We'll upload that file back, and then we'll look at this page again by reloading it. Let's come over to this notepad. Instead of having 3 lectures, let's have one more lecture. Let's paste this right here, and we're not going to be worrying about the URL. Let's just call this lecture 4, and this is going to be a results lecture. Okay, now we're going to come back. We're going to go over to upload. We need to make sure that the file has the same name so that the computer knows that we're uploading a file which is going to be a second version. Let's come over and click on start upload. The upload has been completed, and you can see now we have another version of this file. The first version is on the bottom, and we have the next version right here. You can see there is a change in the time that was there for the upload. So here we have a previous time. Now we have the current time here. You can see there's a change in the sizes, and you can also see now we have a version ID. This was the original version, so this does not have a version ID. If we make one more change, it's going to store that right above that. So let's hit on upload again, add files. You can see we have stored another version of this. Now what we'll do is we'll actually go ahead and do a deletion of one of these files. So if I come here, go over to actions and click on delete. Click OK. This has gotten rid of that specific version for us. However, if I do a hide of this, come over to the original version. Now if I right click and go over to the delete, click OK, it's going to be removed. If I click on show, it's still here because what it has done is it has just attached a delete marker which serves as a cue for the system to make sure that this is not displayed. However, it is still going to be there when we look at the versions of previous files that are here. So all of the files are going to be stored and they're going to remain in storage, because what can happen is you can also accidentally delete a file, and in that case you need to make sure that you're going to be able to restore that file if you have deleted it. If we want to restore that file to the visible files, all we have to do is delete this marker, and now the system will no longer be able to differentiate between this file and the other files which are originally visible. Let's click on hide, and you can see welcome has reappeared for us. So this is all that we're going to be covering in the versioning aspect. Versioning is a very powerful tool, and it allows us to hold different versions of files so that if we make any accidental changes and if something wrong happens, we can easily come back to the previous version and we can restore that version back. Thank you for joining me here, and let's move along.